Let's take a look at our first section in pre-cal, which is section 1.1. And it's on functions and graphs. Okay, so the very first thing I'm going to do is just talk about different kinds of numbers. Okay, very, very quick review from like Algebra 1, even pre-algebra stuff. All right, so the simplest kinds of numbers that we can work with are counting numbers. Okay, counting numbers include your numbers like 1, 2, 3, 4, 5, 6, and so on. Counting numbers don't include negatives. They don't include fractions. Don't include decimals. And what other number don't they include?
Repeating.
Which one?
Repeating.
Nope. We're going to get to those in a little bit. Think about when you count. What number don't you use?
0.
Yeah, you don't use 0. You don't start counting 0, 1, 2, 3. You'd be 1 off. All right, so counting numbers don't include 0. Okay, well, the problem is if we just restrict ourselves to counting numbers, we wouldn't even be able to do some basic subtraction problems. Addition would be okay. Okay, if you add a counting number to another counting number, you would get a counting number. Okay? But watch what happens if I take a counting number, like 3, subtract another counting number, 3. Okay, what would I get if I do that? Yeah, I get 0. Well, the problem is if somebody only understands counting numbers, then you'd say you can't do this. This is impossible. All right? So in order to subtract something from itself, basically we have to invent a new number, and that's 0. Right? So that's where the whole numbers come in. Okay, whole numbers include everything counting numbers do, plus 0. Bless you. Okay, that's the only difference. Okay, but even with whole numbers, we could still run into some problems just doing basic arithmetic. Adding would be okay. Okay, multiplying, if you multiply two whole numbers together, you'd be okay. You'd always get a whole number. How about subtraction? If I subtract a whole number minus a whole number, will I always get a whole number? No. Somebody give me an example.
3 minus 5.
Sure, 3 minus 5. Perfect. Okay, so in your mind, if you only understand whole numbers, we have a problem. You're trying to take away more than you have. That's impossible. You can't take away more than you have if you have like physical objects. All right? So that's where our next set of numbers comes in. That's our integers. Okay, integers now include negatives. All right, so now that we got negatives, I think pretty much any addition problem with integers, you'd be fine. You'd always get an integer. Okay, subtraction, you'd be fine. And if you subtract two integers, you'll always get an integer. Multiplication. What if you multiply two integers together? Will you always get an integer?
No.
Can you give me an example where you wouldn't?
Negative 5 times negative 5.
All right. So you said negative 5 times negative 5. What is that?
25.
25. Is 25 an integer? So integers include all your positives, all your negatives, 0. They just don't include fractions and decimals. So then this is okay, right? Yeah. So that is okay. So what do you think? If you multiply two integers, you're always going to get an integer? Yeah. If you multiply two things that are not fractions, you're going to get something that's not a fraction. Okay? But what could we run into that would be a problem with integers? What operation might not work?
Division.
Yeah, division. Okay, take 5 divided by 3. Okay, now we have another problem. Even with negatives, we can't do 5 divided by 3. All right? You're trying to think of it realistically. Take 5 objects and distribute them to 3 people. You can't do that. Okay, unless you're going to break objects into pieces or parts. Right? And that's where the rational numbers come in. Okay, so rational numbers include fractions. All right, so you've got positives, negatives, fractions, decimals. All right, that's your rationals. And I would say for most everyday purposes, rationals is probably as complicated as you need to get. Okay, you probably use rationals like in cooking, maybe 1/3 of a cup of flour, something like that. Okay, but as we start to get beyond rationals, the everyday uses for the numbers start to get a little more abstract. Okay, they're not used as much. in basic, everyday living kind of tasks. Right? So if your rationals are numbers that can be written as fractions, okay, what about your irrationals? What do you think those are?
Can't be written as fraction.
Yeah, it can't be written as a fraction. All right, so examples of things that are irrational. Actually, somebody give me an example. I think we did one earlier on the calculator. I tried to change this thing to a fraction, and it couldn't do it. Cheryl? Pi. Okay, pi cannot be written as a fraction. Any square root that's not a perfect square. Okay? Square root of 3, square root of 5. Square root of 4 is okay. That comes out to a nice number. Okay, but any square root that's not a perfect square, and numbers like pi, those are irrational. Now you take all your rationals and irrationals, put them together. We call that the real number system. Okay, so most of what we do in this class is going to deal with real numbers. There is another type of numbers you probably studied in Algebra 2. Those are your complex or imaginary. But for the first chapter or so, reals is all we're going to deal with. Okay, and the way I think of it, if you have trouble thinking of is a counting number a whole number, or is a whole number a counting number, which way to think of it? Think of these as places, okay, where the counting numbers is the most specific. Okay, let's pretend counting numbers is Fitchburg. Okay, whole numbers is Massachusetts. Integers is, United States, and then, or New England. And it just keeps getting bigger as you go out. All right, so if you're in Fitchburg, are you automatically in Massachusetts as well?
Yeah.
Yeah, but if you're in Massachusetts, are you automatically in Fitchburg? No. So if you are a counting number, you're automatically a whole number, and you're automatically an integer, and you're automatically a rational. But it doesn't work the other way. Okay? Just because you're in New England doesn't mean you're in Massachusetts. Okay? But if you're in Massachusetts, then you are in New England. Okay? Does everyone understand that kind of idea? How you can think of what's what? Okay? And then real numbers, maybe that's like Earth. That includes everything. Okay? We have some symbols that we use to represent these numbers. So the Z here, we kind of this double line. Okay, if I use that, this stands for the set of integers. Okay, a Q with this vertical line on the left-hand side stands for your rational numbers. And you could kind of think of that like quotient. When you divide, those are your fractions, so Q, quotient. And capital R, those are your real numbers. Okay. Sometimes we might also adjust these symbols a little bit and do something like this. What do you think a Q with a little plus sign would mean? Yeah, it would be the positive rationals. Okay? Or if I put a little minus sign, that would mean the negative rationals, so the negative fractions. Okay, so we'll see that notation as we go. Okay, so in math we have 4 basic binary operations. Okay, a binary operation is an operation that you need to have 2 things to do it. Okay, for example, if I said I want you to add the number 4, well, add it to what? Okay, you got to have 2 things in order to do any of these operations. Okay, that's not true for all operations. Square root. Square root's an operation, you only need 1 number. I could say take the square root of 4, and you could do that. You don't need anything else. Okay, so we're going to look at some properties that we can use with addition. Okay, these properties I guarantee most of you have seen before. It's like associative, distributive, commutative. So we won't spend a ton of time on it, but I just kind of want to refresh people about some of those properties. Okay, in the properties that I'm about to write, I'm going to use the letters A, B, and C. A, B, and C can be any real number, meaning these properties that I give you apply to positives, negatives, fractions, decimals, anything, 0. Okay. Okay, just to clarify that 0 is not positive or negative. Okay, 0 is its own thing, 0. Okay, we already talked about this property today, but I didn't really use this word. Okay? I gave you guys some examples. I said if you add an integer to an integer, do you get an integer? If you add a counting number to a counting number, do you get a counting number? Well, that property that I was just explaining, that's called closure. Okay? So if you add an integer to an integer, and the answer is always an integer, then you could say addition is closed when under the integers. Okay? Adding an integer to an integer always gives you an integer. An example where it doesn't work, we already went over that. Subtraction with counting numbers. Subtraction with counting numbers is not closed, because the problem is if you take a counting number minus another counting number, you do not always get a counting number. Right? So that is not what we call closed. Okay? But with real numbers, pretty much every operation is closed. If you add real numbers, you always get a real number. Okay? If you subtract real numbers, you get a real number. Okay? Real numbers include everything. All right? But I'm just going over addition properties, so I'm just going to mention addition here. Okay? We also have the commutative property, which commutative property says you can switch the order between two things that you add, and you get the same answer. 5 plus 2 is the same as 2 plus 5. In the way I like to think of it, the word commute. Right? If you commute to work, what does that mean? You commute to school, you go back and forth. You move from one place to another. Right? So you can move these letters from one place to another. You can switch places. Okay, how about associative? Okay, associative, there is going to be a property for multiplication. I'm just going to tell you the page in the book that the multiplication ones are on, because they're all very similar. But this one still has to do with addition, but anybody remember what associative means? Yeah, Ruby?
No, I was thinking A plus B plus C, so then the A and B can be separate than C.
Exactly, yep. Associative has to do with grouping. Okay, the order you add things up in. Okay. You can add B plus C first, or you can add A plus B first. It doesn't matter. You get the same answer. Okay, identity property. Identity property is something you can do to a number, and you get the same number back. What would that be with addition? What can you do to a number so that it doesn't change it? You get the same thing back. And you use a different number for multiplication than you do with addition. John?
It's A plus 0 equals A, right?
Yeah. For addition, adding 0 doesn't change the number. Okay, that's called the identity property. What would it be with multiplication? Not multiplying by 0, but 1. Okay, with multiplication, it's anything times 1 gives you back what you started with. The inverse property basically just says if you add opposites together, you get 0. It's kind of like you have something and then the inverse of it or opposite of it. Okay, so if you add inverses, you get 0. Okay, and then the last property is distributive. Okay, so distributive basically means we take what's on the outside and we multiply it to the numbers on the inside. Okay, they have the same properties in your book on page 2 for multiplication. We already went through the identity. It'd be A times 1 equals A. Commutative property for multiplication would be A times B equals B times A. 2 times 5 equals 5 times 2. So it's the same properties, just with multiplication. Yeah, it's the same thing. With multiplication, we really don't have a distributive property. You would never use distributive property with something like this. distributive properties only when you have addition or subtraction inside parentheses. But all these other properties work with multiplication. Does anybody have any questions on these properties? Okay, just basic properties. All right, so an equation. Okay, what's an equation? Well, an equation is basically anything that has an equal sign in it. Okay? It's a statement of equality between two expressions. Okay, so you need something on the left, you need something on the right, you need an equal sign between them. Okay. Anybody give me an example of an equation?
3x plus 5 equals
3x plus 5 equals 0. Sure, 3x plus 5 equals 0. It's perfect. Okay, that's what we call a conditional equation, meaning 3x plus 5 will equal 0 if you pick the right value for x. Okay, here's an example of another conditional equation. 2x equals 12. Okay, 2x will equal 12 if you pick the right value for x. Okay, these are also equations. 3 plus 4 equals 2 plus 5. That's 7 equals 7. Does anybody remember what kind of equation this is? Begins with an I. Identity. Very good. Okay, an identity is an equation that's always true. Okay? Sometimes you get those in Algebra 1. 5 equals 2. That's an equation. It's false, but it is an equation. Okay? If you ended up with something like this in Algebra 1, that usually means it's an equation you can't solve. These are all examples of equations. All right, so I want to look at this equation. I want to try to solve it. And I'm just going to go through, and I'm just identifying each step as I solve. You're not normally going to have to do this, but we just mentioned these properties, so let's try to use them. All right, so my first step. Matt, how would I do the distributive property in this equation?
Distribute
Yeah? And what would that give me?
2x plus 4.
Yep. And that would equal, we'll just keep this the same for now. And you know what? Actually, I think I broke this down. I did it really in 2 steps. 2 times x plus 2 times 3. Okay, Matt jumped ahead. He already said how to simplify it. 2x plus 6. Okay, these are almost the same thing. The only thing I have to do is switch the order, which I'm allowed to do with the commutative property. 6 plus 2x equals 6 plus 2x. Okay, so anybody have a question if I left these on blank on the left-hand side and I asked you, which property did I use to do what's on the right? So everyone would be okay if I gave you a problem like that on the test and said just identify the properties? Okay? All right. All right, that's it for that example. Okay, simple, quick example. All right, so we're going to kind of jump around today a little bit. We're going to talk about coordinates, x-axis, y-axis, okay, all that kind of stuff. Hopefully all stuff you've seen before. Okay, so in one dimension we have a number line. Okay. Even in one dimension we still call the 0 point the origin. Okay, positive numbers always go right, negative numbers go towards the left. In using a number line, one of the most basic things you can do with it is you can give order to numbers. In other words, you can say something is bigger than something, something's less than something. And that gives us our 4 inequality symbols that we use. Let's start with the first one. About Tommy Lee, what's that inequality?
Less than.
Good. Yeah, less than. Eric, the next one?
Less than.
Good, less than or equal to. How about Brendan? The next one?
More than.
Yep, more than or greater than. Perfect. And Cameron, what's the last one?
Greater than or equal to.
Good, greater than or equal to. Okay, so those are the 4 basic inequality symbols. If you already know them, I mean, you don't have to write them down, but if you get confused which one's which, I would write them down. So a lot of times what we do kind of just to start out, especially in algebra, we'll graph things on a number line. And when we graph things, we'll use either an open circle or a closed circle. Okay, does anybody remember which one you use when? When do you use an open circle? When do you use a closed circle? Derek?
I think closed circle is when you're including the number that dies.
Exactly. You use a closed circle anytime you're including the number. Okay, so that's the less than or equal to, greater than or equal to. You use an open circle when you're not including the number. Okay, for less than or greater than. Okay, so let's just practice graphing inequality. Does everybody have what's on the left? Gonna make that bigger. Now I wrote 2 different inequalities above that number line. X is greater than or equal to 2. 2 is less than or equal to x. What's the difference in terms of when I graph between these 2 inequalities? Nothing. They're the same thing. Okay. Generally, when we graph, we like the variable on the left. Okay. But if you see it on the right, I want you to understand how to rewrite it so you can put it the way we normally do. So in this case, Tyler, would I use open circle or closed circle?
Closed.
Yep, I'm going to use a closed circle on what number? 2. Perfect. Closed circle on 2. And the nice thing is if you put the variable on the left, the sign tells you which way to shade. If you put the variable on the right, it tells you the opposite way to shade. All right, so we're going to try to write things like that. Okay, so we're shading all numbers greater than or equal to 2. All right. Okay, here's another one. Same thing, except the way the book wrote it, they had the variable on the right. So what I've done is rewritten it. Notice the way it started out, it's pointing at the y. When I finished, it's pointing at the y. Okay? That's how I know it's equivalent. It's still pointing at the same thing. All right. How about for this one, Kyle? What kind of circle? Open circle or open? What number?
3.
Yeah. Open circle on 3. And am I shading to the left or to the right?
Left.
To the left. All right. Okay, how many people feel pretty comfortable with that? They've done this kind of stuff a ton of times. Okay with it? Okay. And that's generally how we do it. Open circle, closed circle. Well, there's one other way you might see in our book, and I want to just make you aware of it so you don't get confused that the book is doing something different. Okay, the book will sometimes use a bracket or a parenthesis. So the book uses a bracket for a closed circle. All right, so if you're going to graph x is greater than or equal to 2, okay, the way you'd see it in the book would be something like this. Okay, they put a bracket, and then you still shade in the direction you're supposed to shade. In this case, greater than or equal to 2. Has anybody ever seen this done with a bracket before? It's a little different. I generally use the open circle, closed circle. On a test, you can use that too. If you flip through your book and you see this, I just want you to know what it is. Okay, This does require kind of a little bit more thought ahead of time, because you're making a bracket, and you've got to make the bracket face the right way. Versus with a circle, you just make the circle, you don't have to make the circle face the right way. Okay. This one, this time it's going to be facing left. I'm going to shade left. So I'd use a left parenthesis and shade that way. Okay, just a different way to represent the same thing. Any questions on that, bracket or parenthesis? Okay, whichever method you decide to use, I would stick with that method. Okay, just use that. Okay, sometimes you see an inequality and we've got two inequalities on the same line. We read this as an and. Okay, it's a conjunction. And you can basically split it apart into two inequalities just by doing this. There's one. There's two. So the one in the green box says 2 is less than or equal to x, or you can write it x is greater than or equal to 2. And the one in the blue box, x is less than or equal to 9. Yeah?
I was confused there for a second, but back up on the other one, does the arrow always point the opposite way of the opening of the, like greater than or equal to?
If you're using the bracket or the...
No, just with the arrow itself, like the way it points.
Well, if it's less than and you have the variable on the left, it's always going to point
Okay,
left.
so it always,
Yeah. As long as you put the variable on the left-hand side, you can go by the direction this points.
okay, yeah.
If you start writing things backwards by putting the variable on the right, then we're going to get all messed up.
Okay.
So just always put the variable on the left, then just go by whichever way it's pointing.
Okay.
That make sense?
Yep.
Okay, so some problems you come across, again, might have this and in it, and we can write it in this short way. This is generally preferred. Okay? This bottom way is fine, it's just more writing. All right, so when I have a conjunction or an and that I need to write, I'll probably do it the top way. Does anybody know a different way you can write this top one? Still putting an X in the middle? You could put the 9 on the other side and the 2 here. And what would happen to my... Yeah, they would flip. This is the same thing. What's in the black box, the second line and the third line, they're all the same. Okay, and if I wanted to graph that, this time I would use 2 closed circles. So let's go 1 on 2, 1 on 9. And where would I shade? In between them. So you're picking all numbers that are greater than or equal to 2, but you're also picking numbers that are less than or equal to 9. So that's everything between them. Okay. Generally with an and, that's where we shade. Okay. Shade between. Okay, absolute value. Really quick review of that. Simplest way to think of absolute value is it's a distance. It's basically how far a number is from 0 on the number line. Okay, let's just try a couple and see what we get. Okay, absolute value of 6. Okay, Shannon, can you help me out with that one? What's the absolute value of 6? Yeah, 6. 6 is 6 units away from 0. Okay. Eddie, what's the absolute value of negative 3?
3.
3. So anytime you take the absolute value, what kind of number do you always get? Positive, or one other thing you could get? 0. So you get numbers that are not negative, which includes 0 and the positives. Okay. Only number that you get that's not positive when you do absolute value is that one. Absolute value of 0 is just 0. And we said 0 is not positive or negative. So any question on absolute value? All right. So another way the book kind of explains to do it is if you take the absolute value of a positive number, you just keep it the same. Right? You don't do anything to it. If you take the absolute value of a negative number, you basically take away the negative. You take the opposite of it. All right? So what's the opposite of negative 3? Make it positive, positive 3. Right, so using the idea of our number line and absolute value, we can find the distance between 2 points on a number line. And what operation do you generally use to find the change or the difference between 2 points? Derek? Yeah, subtraction. Okay, so if you got 2 points on a number line and you want to know the distance between them, very simple. It's the absolute value of a minus b. Now, what if I switched it and did the absolute value of b minus a? Would that make a difference?
Yeah.
No.
Right, some people say yes, some people say no. Well, first of all, is subtraction commutative? Meaning, can you switch the order and get the same thing? Just subtraction by itself, no. Unless you have 0 minus 0, you could have or 3 minus 3, something like that. But in general, if you have two numbers and you switch the order, you get something different. But I still say it won't matter here if you switch the order. How come? Yeah?
To get rid of the absolute value.
Right, you get those absolute values. Okay? So if you switch the order, the only thing that does with subtraction is it gives you the opposite of the number. Well, absolute value is going to take that away. Okay, you're always going to get a positive answer. So you could really do a minus b or b minus a. It doesn't matter. Okay, so let's find the distance between these 2 points. Taryn, what am I going to plug in for a here? Sure, plug in negative 2. And for b, negative 9. Okay, just be careful with your arithmetic here. What's going to happen when we do negative 2 minus minus 9? It's going to turn to plus. Okay, and Upi, what's negative 2 plus 9? 7. And the absolute value of 7 is 7. So that's the distance on a number line between those 2 points. Okay, any questions on that? Yeah.
Can you just do 2 minus 7 in the absolute value?
In the absolute value?
Yeah, just 2 minus 7, not negative 2. Negative 9. I mean 2 and 9, sorry. 2 minus 9, would that not work?
I mean, yeah, in this case, those are 2 different points, like on a number line. So if you're finding the distance between negative 2 and negative 9, you're trying to find this.
Yeah.
Okay, what you just told me is equivalent, but you're over here. You're finding the distance between positive 2 and positive 9. Different spot on the number line. It ends up being the same answer, but yeah. All right. So next thing is we're going to take our number line and extend it into 2 dimensions. Okay, that gives us the Cartesian coordinate system. Okay, once we extend that number line into 2 dimensions, now we say we have an x-axis, which is horizontal, and a y-axis, which is vertical. Okay, where the axes cross, that's our origin. Okay, those axes divide the coordinate plane into 4 regions. I've numbered them with Roman numerals, region 1, 2, 3, and 4. Does anybody know what we call those regions? Yep,
Quadrants.
they're quadrants. Okay, and when you're in quadrant 1, okay, all your coordinates are positive, positive. Right? Because as you go to the right on the x-axis, that's positive, and as you go up on the y-axis, that's positive. in quadrant 2, all your coordinates will have this form. The first number is negative, second number is positive. And that's because on the x-axis, as you go left, it's negative. As you go up, it's positive. Okay, and then quadrant 3 is where we have negative, negative. Quadrant 4, positive, negative. Okay, what about the point like 0, 2?
No, so it's going to be on the y.
That's on the y-axis. Okay, so if you have a point that has a 0 in it, you're not in a quadrant. You are on an axis. And there's a couple names for this. You can call, when you have the parentheses, 2 numbers and a comma between them, you can call it a coordinate or an ordered pair. Anybody know what we call something like that?
Coordinate trio.
Well, you can call it just a coordinate, or the second word, or the second thing, you're kind of on the right idea, ordered triple. Yeah, you're on the right track. And the only difference in 3D is now you have an x, a y, and a z-axis. Does anybody know how many regions that would break up the space into? 8. Yeah, it would break it up into 8 areas. Does anybody know what you call 8 areas? Not quadrants, but what's the octants? Yeah, in 3D we have octants, right? And there's 8 of them. Okay, for now, we'll stick with 2D. Does everybody have that? All right. Generally, when we do graphing, we try to use a grid or graph paper, or we can use our calculator. All right. So, these are the last couple things. So on the calculator, I want to practice zooming. Okay, so sometimes we're going to have a function we need to graph. It might be off the screen. So I'm going to show you how you can change your window. So for this part, there's not really going to be a lot of writing. Okay, if this was a homework problem, you could just try it on the calculator. Okay, so first thing, we got to turn our calculator on. And let's put something on the screen that we could actually see in this window. Okay, rather than just make a window, let's make it so we can see something. Right, so I'm going to give you a picture to graph. Okay, so I want you to press y equals. And on the y equals screen, I want you to type in, press the button right next to alpha, x squared, and type in plus 12. Okay, after you type in x squared plus 12, I want you to press the zoom button. Okay, it's right at the top in the middle. And the 6th option down is standard. Okay, what standard is going to do is it's going to set the window from negative 10 to 10 on the x-axis and negative 10 to positive 10 on the y-axis. Okay, so choose the 6th option down.
Could you go back? What are we typing again?
X squared plus 12.
How did you get to the state option?
You press zoom, and it's the 6th one down. Okay, now, does everybody have a picture on their screen? Anybody see any picture drawn on the screen? No. Yours says what?
I see a graph.
You see a graph? You did zoom 6?
Yeah.
Do it again. Okay, and make sure you have typed in x squared plus 12. Anybody else having a problem with theirs? Is that an error? No, we got error fixed. Okay. The reason we can't see this graph is because it's off the screen. Okay, yours should look just like that if you've done everything correct. Okay. Now we're going to make it so we can see it. Right? What you want to do now is you're going to set your viewing rectangle. Okay, that's under what we call window. Okay, press window. Okay, when they give you something like that, this is your x min, x max on your axes. Okay, this is your y min and y max. Okay, so we're going to type in those numbers into the window. Be careful that you don't switch the min and the max. If you do that, the calculator is going to give you an error. Like if you try to set the max at negative 20 and the minimum at positive 20, that won't work. So just take negative 20 to 20 and go down to the min, negative 20 to 20. Don't worry about the scale, delta x, trace step. We're really not going to play with any of that. All the scale really does is it changes how many tick marks you see on the screen. So right now we're displaying a tick mark every 1 unit. If you want to display a tick mark every other unit, you could put it on 2. But that doesn't really matter. Okay, does everybody get the negative 20 to 20 typed in? Okay, now when you hit graph, hopefully you should see the picture now. All right. So this kind of thing is going to happen a lot. We'll sketch a picture, we'll look at the screen, we might only see part of it. And we got to change our window so we can see the rest of it. All right. So as we go, we're going to kind of learn what these shapes look like. Okay? So when you graph something that's squared, that's a parabola. Plus 12 shifts it up 12 units. So I knew that in a window of negative 10 to 10, if I shifted it up 12, it'd go right off the screen. That's why I did that. Okay. Question on how to set your viewing rectangle. And that can be hard. Okay, sometimes we got to play with it a little bit and try to figure out and take some guesses and adjust it and then guess again. It's not always super easy to find the right window, especially when you have graphs that go up into the thousands. Okay, sometimes you got to make your window pretty big, but you wouldn't want to make it too big. Like if I do zoom 3, okay, and it gives me a little cursor and then hit enter, what it's going to do is it's going to zoom out. Okay, and if I keep zooming out, eventually what's going to happen is I'm not really going to be able to see the parabola anymore. See how skinny it's getting? Eventually it would look like it's just part of the axis. Right? So that's not a terribly good window. I think I've zoomed out too much now. Right? So I probably want to zoom back in a little better. And last two things we're going to look at. Distance formula and midpoint formula. Okay, so distance formula is basically used to find out how far apart 2 points are. And that's your distance formula.
Can you get back to like the normal calculator after you go to the graph?
After you graph, you can press second and then press quit. And that'll bring you back to the home screen. Is that what you're looking for, Ted?
Yeah.
Okay. You're welcome. Okay, does this formula kind of look like anything? You square something else, you add them up. It's another formula in math where we square something, we add them together. It deals with triangles.
Quadratic
Not the quadratic formula, but there are some things you do square in there, like b squared minus 4ac. I'm thinking of having to do with a triangle. Derek? Yeah, that's all that this formula really is. It's the Pythagorean theorem. Right, so the idea is if you had, let's say, point P right here. Let's put point Q right there. And what are the coordinates of point P? X1, Y1. And coordinates of Q, X2, Y2. Okay, we're just trying to find the distance between these 2 points. We're trying to find that. Well, one way to easily do that is basically to make a triangle out of that shape. Okay. So if I extend the bottom side, okay, or kind of create that bottom side, create another side going straight up, and that's a 90-degree angle right there. Okay, now look at just the bottom side. Pretend that this is a number line. This point is at coordinate x1. This point is at coordinate x2. What operation did we say we used to find out how far apart 2 points are? Yeah. Yeah, we subtract them. All you have to do is take x1 minus x2. Right? And if you subtract it, it would take the absolute value. We're not going to have to worry about doing that. You'll see why in a second. But if you just find the difference between these 2 points, that tells you how far apart they are. Okay? And then the same thing vertically. This bottom point is at y1. The top point is at y2. If you want to know how far apart they are, just subtract them. y1 minus y2. Okay, so now we know the length of the side in red. We know the length of the side in green. We can use the Pythagorean theorem to find what's really the hypotenuse. Okay, that's all we're really doing. Okay, so here's our Pythagorean theorem. The only thing is, think of this side as c. We don't want c squared. We want c by itself. So what would you have to do on both sides to get c by itself here?
Square root?
Yeah, take a square root. And there is basically your distance formula. Just plug that in right there, and plug that in right there. So every time you use the distance formula, you're really finding the hypotenuse of a triangle using the other 2 sides. That's all you're doing. Any question on that? All right. Let's try to find the distance between the point 1,4 and 5,6. Okay, sometimes, especially in like algebra 1 or geometry, I'll suggest people label what's x1, what's y1, and so on. It's up to you. If that's helpful, go for it. If you don't need to do that, then I wouldn't bother. It's generally how I start. Just fill out my formula so I have 4 spots to plug in all my numbers. And Amanda, can you tell me what I'm going to subtract in the first set of parentheses? Yeah, 1 and 5, and really you can do it in either order. Even though subtraction is not commutative, you're going to square it. So the square is going to take away any sign that would have been negative. All right, so let's do 5 minus 1. All right, so this is like x1, y1, x2, and y2. Okay, in my second set of parentheses, Nick, what will I put in there? Yep, so we got 6 minus 4. Okay, so that's going to give me the square root of 5 minus 1 is 4. Jamie, 4 squared is how much?
16.
Good, 16. John, 6 minus 4 gives me 2. Squared is 4, which is the square root of 20. And what is the square root of 20 reduced to?
2 and 5. I mean 2 and square root of 5.
2 square roots of 5. Okay, everybody know how to reduce a square root like that? know I helped people last year in study hall with that, so square roots. Okay, so that's important to know from Algebra 2, how to reduce a square root. If you forget, the way I do it is I take the number 20 and I break it up into 2 square roots. Okay, a factor of the number 20 is 4 times 5. I got to factor 20, so one of the numbers I can take the square root of in my head. So you might be thinking, well, why not 2 and 10? Well, I can't do the square root of 2 in my head, and I can't do 10 in my head. But I can do 4. The square root of 4 is 2. And the square root of 5 is just left over. Okay. So any questions on distance formula? All right. And last thing, midpoint formula. Okay. Generally, as we start to go through more lessons, we don't do this many topics in one day. It's just, this is all review stuff, so we're just trying to get some of that review stuff out of the way. I hope that everything I've shown you today you've mostly seen before. Here's your midpoint formula. Okay, so if you're given 2 coordinates, basically you add the x's and divide by 2, add the y's and divide by 2. What are you really doing here? You're taking 2 numbers, you're adding them together and dividing by 2. There's a name for that. Derek? Yeah, you're averaging, which makes perfect sense. Okay, midpoint, you're trying to find what's right in the middle of 2 numbers. So add the x's and divide by 2, add the y's and divide by 2. You're averaging. Average the x's, average the y's. All right, so our last one will be to find the midpoint between these 2 points. Okay, so I usually set it up just like that. That way I got everything written out that I need. All I have to do is plug in my 4 numbers. Bless you. Okay, how about Fernando? What's the 2 numbers I'm going to add in my first numerator? Yep, we got -5 plus 3. And the 2 numbers I'm going to add in my second numerator? How about Kyle?
2 and 7.
Yep. Got 2 and 7. Okay, simplify it. -5 plus 3. Jill, what is that?
That's -2.
And then divide by 2.
-1.
Good. -1. And Cheryl, the second part, 2 plus 7? 9. And does 2 go into 9? It doesn't go in evenly. So if you want to leave it as 9 halves, that's fine. Or you could change it to 4.5. Any questions on the midpoint formula? All right, so we're able to end a little bit early. We've got about 10 minutes left. So I'm going to give you a little time to start the homework, okay, which is on page 11. It's 5 to 16, 20 to 23, 28, 31, 32, and 34.